everybody. Professor Mohammed Sharaf with you. Today our model is it's about vertical wind turbine Simulink model. Let's go and run our model and see what we can do about that. First of all, go to your destination, specify your destination folder, and which drive, which location folder. Go to your folder, double clicking on your model, and your model should be appear like this. Be sure to go to view in menu bar, and you have to select this show model browser. Okay, all of these buttons, and click here. Okay, our model is ready to rumble. Anyway, our model is simple. It's just one block. It's about vertical wind turbine. This model, the operating range of power of these modules, or for this model itself, for up to no more than 12 kilowatt per one module, or I think it's up to 50 kilowatt per module. I will discover this. I forget, because I did this model. I established this model before and I forget. Okay, let's go. Double clicking on your model, and you have to specify. Okay, it's from 0.2 kilowatt up to 50 kilowatts, no more than this per module. Okay, just double clicking on your model, and you can assign some inputs such as atmospheric temperature and pressure. Okay, and let's go for design. Suppose I am going for I have a plant farm, and I need to upload around 1 megawatt for the public grid, and I would like to use 10 kilowatt per module for vertical wind turbine. Vertical wind turbine is quite interesting because it's there is no tail, there is no Y system. It can rotate up to safe moderate speed, or safe speed of rotating. Okay, but be sure that rated power per unit. I'm sorry, I have to go here and Control M, going to parameters and going here. Okay, this is not horizontal, this is vertical wind turbine. Vertical, yes. Okay, let's apply. Okay, so be sure that rated power per module is less than I'm sorry, this is, I committed a mistake. I have to return back again here. I think this one, I'm sure this is not. You have to go here and or here and add edit. Okay, I'm just Control X, put this here, and Control X, and put this one here, and let's remove this one. Okay, hit apply, and I think this okay, hit apply, and okay, now we are ready. I'm sorry. Okay, be sure that you suppose I need for 10 kilowatts per one unit. This parameter should be less than the total power. Okay, anyway, let's hit apply and okay, and hit run. Let's hit run. Okay, our model, these are our results. We can discover a mass flow rate of the air, starting wind speed. because this is a design model. So our input selections are telling us that we have to choose or pick an area for starting wind speed not less than 2.9 meter per second, and our rated wind speed should be not less than 12 meter per second. This is rotor diameter, 5 meters. Okay, 5 meter diameter, rotor swept area, fin length, RPM, and torque, and wind power. Okay, and this is power coefficient is quite low. Okay, number of wind turbines. So we are going to use around 100 wind turbine in order to provide 1 megawatts. Number of blades, 5 blades, and voltage and cost of the set. Okay, very good and very nice. So suppose I'm going to I need to discover the effect on you can input matrix. Suppose I need from 1 kilowatt step 1 turbine up to 50 kilowatt. Let's go and hit run and see here. Let's go and see our results. Okay, so we have here, let's go in Matlab workspace, and we can see this is our area. Okay, this is our area profile. Okay, power coefficients. This is your power coefficients according to this is kilowatt. Let's go for kilowatts. I think this is horsepower. Okay, let's do horsepower versus area for example. Okay, I'm going here. Let's go and select some figures. Okay, let's go and clicking here at add data. I need to draw horsepower per module versus power coefficients. As you can see here, you can go here and make this white. For this one, let's go for cost. Okay, this is your specific cost per unit, US dollar, and we have here rotor diameter. According to the power selection, fin length. Okay, and we have here we can draw some with air mass flow rate. Okay, for this one we can draw versus a number of wind turbines. Okay, increasing the power surely will reduce number of wind turbines. And we can go here, and this is our torque, for example. Okay, torque. Okay, so you can click shift, passing through each figure, and X, Y, remove the boxes, and you can reform. Matlab is programmable and allowable for many criteria, so you can change your you can change your length, thickness of your curve. Anyway, so this type of data extraction, you can enter your inputs as a matrix, and sure you can reform this based on your selection. Okay, let's go here, and suppose I am going for Control M over the block parameters, and let's go here for total farm power. Suppose I need to do to make it a slider. Let's do it as a slider, and suppose I need 1000 kilowatts minimum power. Sure, no less than 1 kilowatt, up to suppose it's 10,000 kilowatt. You can control this limit, it's up to you. Okay, and hit apply. And for this is a dial, I'm sorry, a dial. I need to make it as a slider, I'm sorry, slider horizontal. I'm sorry again. My input value is 1000. Minimum value 1 kilowatt up to 10,000 kilowatts. Okay, horizontal. Let's set apply. For unit, we have to change this. Suppose I need to go for slider. I will begin from 0.5. Minimum value is 0.2 up to 50, because we already checked this before. Current row and horizontal. Atmospheric pressure, I will keep this as it was. Okay, so we can go dynamically, I mean okay, let's go dynamically and discover what is going on with. But before going dynamically, you have to assign your outputs. Therefore I have to do the following. Which output data I need to discover? So I have to check all of these signals, okay, and click on stream selected signals to data inspector. Okay, now our data is we'll go directly to the signal. Control C and double clicking and Control V, because I will not wasting my time. Control C, typing, Control V. Okay, because this I need to discover the effect of changing the power, post power, total power and module power on my results. Control V, yes. I'm going here. Okay, and we have to go here and set our simulation time into infinity, and let's double clicking and go inside here. Okay, so we can use dashboards in order to change all. Okay, let's go, and I'm sorry, suppose I will begin with 100. Okay, let's hit run and discover the effect on our output. Let's increase the total power. I'm increasing the total power. Okay, increasing the total power. Then I will increase the module power of the module. Suppose I need to go to up to 50 kilowatt per module. I'm going for 50 kilowatts. Okay, for of course 200 kilowatts. Let's go for 50. Okay, maximum allowable range. Okay, and let's increase the total power of our farm. Suppose I'm going for 500, or let's control minus. Yes, 2009, 3000, 5000, 5 megawatts, 5 megawatts. Okay, that's enough for this, and hit stop. Okay, let's go and discover. Okay, I'm sorry, let's go and discover our results. Let's go here. Okay, so suppose I'm going to discover this is module power. Okay, number of blades, changing according to increasing your number of turbines, and total horsepower. It's this is input, and this one is input too. Air mass flow rate, changing according to the change in module power, starting wind speed, power voltage, cost of the set changing according to the power, rated wind speed. Okay, you can put rated wind speed with starting wind speed, and you can compare between two figures: rotor diameter, rotor swept area, and show fin length. Okay, torque, wind power, and efficiency, power coefficient efficiency. Okay, increase it, the efficiency is increased because we increased the module power related to the total power of the farm. It's quite, this model is straightforward and easy. You can download it and use it. It's quite normal for vertical wind turbine model. And finally, I would like to thank you very much for your interest in our model, RETS library. Don't forget to like, share, and subscribe. Thank you very much.